Alright, welcome back. Today we're going to look at Chapter 7 on sedimentary rocks. So what is a sedimentary rock? Sedimentary rocks are products of mechanical and chemical weathering. They comprise about 5% by volume of the Earth's outer 10 miles of crust. And they provide evidence of past environments, such as the information about sediment transport, and they often contain fossils from marine life. Sedimentary rocks are important for economic considerations because they may also contain coal, petroleum, natural gas, and sources of iron, aluminum, and magnesium. Sediment originates from mechanical and or chemical weathering, and the rock types are based on the source of the weathering material. First, we have detrital rocks. These are transported sediment as solid particles. And then we have chemical rocks, sediment that was once in a solution. So the chief constituents of detrital rocks include clay minerals, quartz, feldspars, and micas. Remember, there's two types of micas, the black mica and white mica. Particle size is also used to distinguish among the varieties of rock types. So here we see different particles. You can have something as small as clay or silt going up into sand, and then different sized particles like a granule or a pebble, a cobble, or a boulder. Let's see, large. What are some common detrital sedimentary rocks that we find? We have shale. This is a mud-sized particles that are in thin layers called lamina. The most common sedimentary rock is shale. And then we have sandstone. These are sand-sized particles that have been cemented together. They are primarily made out of the mineral quartz. Here's a piece of shale with a plant remaining in it. This may have been in an ocean somewhere. And here's a very common rock that we find here in the Ozarks. This is quartz sandstone, and you can see up close it's really like just a bunch of sand cemented together, and if you would rub your fingers on it, you would be able to rub off some of the sand into your hands. And oftentimes we see banding layers in this. And you have an example of sandstone in your lab kit. We also have what we call conglomerate or breccia. Conglomerate is kind of just a mishmash of everything you can imagine. It's just a bunch of different gravels, different sizes, different shapes, different types. And then breccia is really composed mainly of large angular particles that have a lot of sharp edges to them. So here's conglomerate. Really, this is just something you'd see, you know, in a corner lot somewhere. Just a rock on the road. All kinds of different rocks meshed up together in different sizes and elements. And here is a large conglomerate outcrop near a cave. And then here's breccia. And this is, like I said, angular shapes. They have sharp edges to them. And then the rock itself can have some sharp edges because of that formation. Well, let's look at chemical sedimentary rocks. This is a different type than the weathered rock. These consist of precipitated material that was once in a solution. And the precipitation of material occurs by inorganic processes and organic processes, which means a biochemical origin. So the common chemical sedimentary rocks, this is very common here in the Ozarks, is limestone. It's the most abundant chemical rock, composed chiefly of the mineral calcite. We see a lot of marine life in limestones, formed from coral reefs, coquina, broken shells, and chalk, which is really microscopic organisms on the seafloor. We can also have inorganic limestones, including travertine. So here's a picture of coquina, and we see in this some shell life from the ocean floor that formed this, the fossil remains of the shell life. Here's oolitic limestone, more of a granular size to it. Some other types of chemical sedimentary rocks we see are dolostone. These are typically formed secondarily from limestone. And chert. Chert is a type of quartz, and these come in different varieties, including flint and jasper. Here's a beautiful rock, and if you ever go tourist sighting In the Ozarks, if you go to Branson, if you go to Eureka Springs, Harrison, Arkansas, and you go to a local store that sells, kind of Ozarkian stuff, we see this stuff that's being sold. It's called Agate. And this is a really beautiful rock. It's semi-transparent, and you can put a light behind it and have a night light. They sell these at Fantastic Caverns and places around there. We also have evaporites, and these are rocks that are formed from the evaporation of precipitates. These include rock salt and rock gypsum, and we have a lot of this in the Ozarks as well. Another common chemical sedimentary rock is coal. It's different from the other rocks because it is composed of organic material, and there is a finite amount of coal in the world. And so the various stages of coal formation include the plant material itself. It dies and starts to deorganize and become peat, and then lignite and bituminous. And we see that here, and this is in your book. How do we turn sediment into rock? There are many changes that need to occur for sediment to become rock after it's deposited. We have a term called diagenesis, which is chemical, physical, and biological changes that take place after sediments are deposited. This occurs within the upper few kilometers of the Earth's crust. So this diagenesis includes the recrystallization, the development of more stable minerals from less stable ones, and lisification, where sediments are transformed into solid rock by either compaction and cementation, or natural cements, which include calcite, silica, and iron oxide. Sedimentary rocks are classified according to the type of material that makes them up, and we have two types, two major groups, detrital and chemical. So within the sedimentary rocks, we have two major textures that are used in the classification of sedimentary rocks, clastic and non-clastic. Clastic rocks have discrete fragments and particles inside of them, and all detrital rocks have this type of texture, a clastic texture. The non-clastic rocks have a pattern of interlocking crystals and may resemble an igneous rock from lava. This graph is in your book as well, the classification of sedimentary rocks from the very grain sizes and also the various chemicals and organic sediments that might form them. Sedimentary environments are geographical, where the sediment is accumulating, and this geographical location determines the nature of the sediment that can accumulate, including the grain size and the grain shape. So we have various types of environments that the sedimentary rocks can be found in. Continental environments are dominated by stream erosion and deposition. It could be glacial, where an ice sheet has gone over it, and wind erosion. The mineral environments for marine rocks are shallow, generally up to about 200 meters, 500 feet, deep seaward of continental shelves. Now near a shoreline, we can have a transitional area between the water and the land, and these are tidal flats, lagoons, and deltas, such as the Mississippi Delta down near New Orleans. Different sediments can often accumulate adjacent to one another at the same time, and each unit possesses a distinctive set of characteristics reflecting the conditions of a particular environment. The merging of adjacent facies is a gradual transition. So here we have the limestone gradually going into a shale environment into a sandstone environment near the shoreline. The structures of sedimentary rocks can provide a useful informational tool in the interpretation of Earth's history. And the types of sedimentary structures include the strata, or beds, most characteristic of sedimentary rocks, bedding planes that separate the strata in the rocks, and cross bedding, where two different layers cross over each other. So here is some cross bedding in sandstone, where the different deposits have been deposited there by water, wind, erosion, ocean life, and you see the different layers there. We have different types of structures in sedimentary rocks, and these include graded beds, ripple marks, mud cracks, and the fossils themselves. Here are ripple marks, and this is when you have a rock near a riverbed, a stream, near the ocean, and you get these little river marks in them. Mud cracks, where you have had water standing before and it had made mud, and now the water is gone and they crack from the dehydration of the area. That's the end of chapter 7, and I look forward to seeing your discussion boards this week. Thanks.